Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Haziq bin Muhammad Salleh. My metric number is 1212897. So today I will present about food irradiation that are related to nuclear chemistry. So first of all, in line with today's development technology, most of the food we buy has actually undergone food irradiation. This is mainly the import and export process of food, and also this is because the food needs to remain fresh and in a good condition when sold to the customer. Process that use ionizing radiation to preserve food, eliminate pathogen and extend shelf life. The radiation kills inactivate harmful bacteria, parasite and insect, also inhibits sprouting in foods like potatoes and onion. This technology also is widely used in many countries and has been endorsed by major health and regulatory organizations, including the World Health Organization, Food and Agriculture Organization, and US Food and Drug Administration. So for food irradiation, there are three processes that will be done. The first one is the preparation of the food. So the food must be cleaned and sorted, and some of the food will be packaged first before exposed to the radiation. After the preparation is finished, the food will be exposed to ionizing radiation. So there are three parts of ionizing radiation. First is gamma rays. It is emitted from radioactive forms of the element cobalt-60 or of the element caesium, which is caesium-137. It is used routinely to sterilize medical, dental, and household products. The second is X-ray. It is produced by reflecting a high energy stream of electrons of a target substance. It is usually one of the heavy metals into the foods. It is also widely used in medicine and industry to produce image of internal structure. And lastly is electron beam. It is similar to X-ray and is a stream of high energy electrons propelled from an electron accelerator into the food. So what happened to the food that have been ionized? So the radiation before disrupt the DNA of bacteria, virus, and parasite in the food. This prevent them from reproducing or functioning, and effectively killing or neutralizing them. Okay, so we move to the benefits of the food irradiation. There are four benefits that have been found of the food irradiation. Firstly is it can reduce the needs for preservative. It can permit extended preservation without the use of chemical addition. Next, the food safety. So the risk of foodborne infection is low by eliminating dangerous microbes including Salmonella, Listeria, and E. coli. The third one is it can extend shelf life. It's delay in the ripening, sprouting, or spoiling of foods like potato, fruits, and vegetables. So the food to be sold can be stored longer without affecting the food. And lastly is pest control. It removes pests and insects from imported or exported food and store grains without the use of chemical fumigants. It shows that the food irradiation is better than applying chemical fumigants, which usually has a lot of impact on the health of our bodies. Okay, for the next slide is about the application of the food irradiation. So nowadays food irradiation has been widely used and applied in many types of foods. First of all is fruits and vegetables. So the food irradiation extends the shelf life of fruits and vegetables by delaying ripening, sprouting, and spoilage. Low doses 0.2 until 1 kilogram are used to inhibit sprouting in roots crops like potatoes and onions. For fruits such as mangoes, papaya, and guava, irradiation prevents infestation by pests like fruit flies, making them suitable for export by meeting quarantine regulation. This method also reduces the microbial load on fresh produce, minimizing risk of foodborne illness. So the second one is in meat and poultry. Irradiation in meat and poultry serve as an effective tool for pathogen reduction. Doses of 1 until 7 kg eliminate harmful bacteria such as Salmonella, E. coli, and Listeria monocytogenes, which are common source of foodborne illness. It also slows down spoilage by reducing microbial activity. By lowering the risk of contamination, irradiated meat products ensure enhanced safety without compromising nutritional quality or taste. So, the third one is spice and herbs. Spice and herbs are often contaminated by bacteria, mold, and yeast due to their prolonged exposure to the environment during production. Irradiation at higher doses, 10 until 30 kg of Y, effectively sterilize these products, eliminating microbial contaminants and pathogens like Clostridium botulinum spores. This is a superior alternative to chemical fumigation as it leaves no residue and preserves the product's flavor and aroma. So the lastly is seafood. Seafood is highly perishable and prone to contamination by pathogens such as Vibrio species and parasites. Irradiation of seafood is 1 until 5 kg Y. Reducing spoilage eliminates parasites like anisakis and lower the risk of bacterial infection. It also helps maintain the sensory qualities of seafood such as texture and flavor while extending shelf life, especially for exports. So, the food irradiation offers a safe and effective method to enhance the safety, quality, and longevity of various food products. Okay, so we look at the concern and misconception about the food irradiation. One common concern about the food irradiation is the perception that it makes food radioactive or unsafe for consumption. This misconception arises from lack of understanding of the process, which involves exposing food to controlled doses of ionizing radiation to eliminate harmful microorganisms, pests, and parasites. Unlike radioactive contamination, food irradiation does not alter the food's atomic structure, while minor change in taste, texture, or color may occur. These are minimal and do not affect the food's nutritional value significantly. Research has consistently shown the irradiation preserves the safety and equality of food without introducing harmful substances. Despite its safety, some consumers remain wary, associating the term radiation with nuclear hazard. To address this fear, regulatory bodies have emphasized the importance of public education. Proper labeling, including the use of the internationally recognized Radura symbol, help consumers identify irradiated foods and foster transparency. So we can look at the slide. At the middle of the slide, there is a Radura symbol which is labeled at a food that have irradiation process. So for the safety and regulation, food irradiation is rigorously regulated to ensure consumer safety. It is endorsed by reputable organizations such as World Health Organization, WHO, the Food and Agriculture Organization, FAO, and the US Food Drug Administration, FDA. These agencies have evaluated extensive scientific data, in concluding that irradiation is a safe and effective method to improve food safety and extend shelf life. Regulation require irradiated foods to carry the Radura symbol and a clear label indicating the process, and also this ensure the consumer are informed and can make educated choice for their food. So we can conclude that the food irradiation is a proven, safe, and effective technology for enhancing food safety, extending shelf life, and reducing foodborne illness. It helps control pests, eliminate harmful pathogens, and maintain the quality of various food products, including fruits, vegetables, meat, poultry, spice, and seafood. Endorsed by leading organizations like WHO, FAO, and FDA, the process is strictly regulated to ensure safety. Although some consumers have misconceptions about its effects, education and proper labeling, such as Radura Steam Bowl, are improving acceptance. Overall, food irradiation is a valuable tool in modern food processing, contributing to a safer and more sustainable food supply. So thank you for watching this video.